So as we look at radian measure, the definition of a radian, 1 radian is the measure of a central angle. 1 radian is the measure of a central angle that intercepts an arc equal in length to its radius. Okay, an intercepted arc, if I have the radius, say here, and this is my angle theta, this is the intercepted arc, and S stands for the intercepted arc, and this would be my radius. Okay, 1 radian's the measure of a central angle that intercepts an arc equal in length to its radius. Now, I don't know that that's equal in length right there that I just drew, but I think you can see that we could come up with the definition for theta. Theta is equal to the intercepted arc divided by the radius, and this is where theta is in radian measure. So we are going to be looking at radian measure. We'll be looking at degrees and how we can convert from one to the other. But you'll need this formula, that the measure of the central angle is the angle from the origin that goes from the center of the circle to the edge of the circle. The measure of that central angle is S over R. Intercepted arc, the measure of the intercepted arc over the measure of the radius. Okay, intercepted arc, if I were to start my angle right here and rotate it all the way around a complete circle and end it up right here, the intercepted arc is equal to what? Okay, 360 degrees if we're doing degrees. It's equal to the circumference of the circle. Would you buy that? That intercepted arc is equal to the circumference of a circle? And what is the formula for circumference of a circle? How about 2 pi r?
Yeah, that's
Will you buy that?
Yeah.
Okay, so if we know that theta is equal to S over R, could we say that theta, which is S over R, is equal to, what was the intercepted arc on that complete rotation? 2 pi r. So the intercepted arc is 2 pi r over the radius. Notice here, these are going to cancel out. And for that complete circle, theta is equal to 2 pi. One complete revolution in radian measure is 2 pi. And you can put 2 pi radians. Usually you won't see the word radians, but that is radian measure. One way you know whether you're dealing with radian measure or degrees in your textbook is if it has degree, it's always degrees. If there's no designation, then it's radian measure. Calculus, we almost always use radian measure. So we're going to be doing a lot of radian measure. So you do not, it is 2 pi radians, but you don't have to write out radians each time. If you don't see radians and if you don't see degree, that means it's in radian measure. Yes, sir?
Is the radian 1?
If 1 complete revolution is equal to 2 pi radians, what would half of a revolution be equal to in radian measure? pi radians. What about 1/4 of a revolution?
1/2.
Pi over 2 radians. What about 1/6 of a revolution? Well, that would be 2 pi over 6, pi over 3 radians. And as I said, you can write radians, but you don't have to each time. I'm just going to abbreviate. Okay. Our circle here, I've set it on a coordinate plane. And the coordinate plane is divided into 4 quadrants. Remember, this is quadrant 1. Quadrant 2, we use Roman numerals to name them. We don't use Arabic numerals. Quadrant 3 and quadrant 4. So if we think about the angle in each quadrant, in quadrant 1, theta is between 0 radians and pi over 2 radians. Because this is 1/4 of a revolution.
What's the, sorry, what's this, before the theta, what's the?
In quadrant 1.
Yeah.
Quadrant 1.
After that. Sorry.
0.
Okay,
Theta is between 0 and pi over 2.
okay, just wanted to make sure.
In quadrant 2, theta is between pi over 2 and pi. In quadrant 3, theta is between pi and 3 pi over 2. And in quadrant 4, theta is between 3 pi over 2 and 2 pi.
So are you using like
The angle here can be named as 0. It can be named as 2 pi. If I start here and go all the way around, it could be 2 pi. If I start here and go in the negative direction, we could also name it as a negative 2 pi. So I think you can see that coterminal angles differ by how much? Coterminal angles. If I have this, do it in blue, and that's just going to be 0, and then I look at the red and I went in a counterclockwise direction, how much did those differ by? 2 pi. Okay, what if I, let me see here. Let's try a different color. We'll do purple. What if I start at 0, go all the way around, and then go all the way around again? 4 pi. That would be 4 pi. So we can see that coterminal angles can be found by adding or subtracting, or actually can be found by adding 2 pi n where n is an integer. Okay, that means n can be positive, n can be negative, n just cannot be a fraction. Okay, so I want to find 2 angles that are coterminal with, say, pi over 6. I want one of them to be positive and one of them to be negative. and two angles coterminal with pi over 6, one positive and one negative. So we can take pi over 6 and add to that 2 pi times 1. That means I'm going to say my angle started right here, and I'm not going to draw the circle, but if it was about right here, and I want an angle that's coterminal, then I can go all the way around 2 pi times. So that represents that coterminal angle. So this is equal to pi over 6 plus 12 pi over 6, or 13 pi over 6. So 13 pi over 6 is coterminal with pi over 6. I could add another 2 pi and get another angle that's coterminal.
Where did you get the 12? That's what I'm wondering.
What is 2 pi?
12 over 6.
12 over 6. 12 pi over 6. Negative angle, we can do pi over 6 plus 2 pi times negative 1, which would be pi over 6 minus 12 pi over 6, or negative 11 pi over 6. And that angle would start at the positive x-axis and go here. That would represent negative 11 pi over 6 in red.
Wait, how?
Take a second and find an angle coterminal to 9 pi over 4. I want two coterminal angles, one that's positive and one that's negative. Now let's think about this one. It's a little bit different. If I divide 9 by 4, what do I get?
2 and 1.
I get a little over 2. So could we add or subtract 2 pi and still have a positive angle?
Yes.
Yes, we could. Or we could think of it as adding 2 pi times negative 1. But really what we're doing is subtracting 2 pi. Minus how many pi over 4?
2.
2 pi is how many pi over 4?
8.
8 pi over 4. And that gives me pi over 4. Okay, so that's still a coterminal angle that's positive. How would I get a coterminal angle that's negative? What would I need to do to get a coterminal angle that's negative?
Like greater than 1.
Do what?
Like instead of negative 1, like negative 2.
Okay, we could multiply by something greater than negative 1, and I think now that's what I heard somebody say over here. So 9 pi over 4 plus 2 pi times negative 2, which would be negative 4 pi. So 9 pi over 4 minus, what's 4 pi? How can I convert that over 4? 16 pi over 4. And that's going to be what? Negative 7 pi over 4. Complementary angles, which we talked about in geometry, but it's we have to think about it a little bit differently in trig. Two positive angles are complementary if their sum is pi over 2. What was the definition in geometry? Do you remember?
180.
Not 180. 90 degrees. If we're dealing with degrees, two angles are complementary if they're positive and their sum is 90 degrees. We didn't have to worry about positive or negative. We didn't have to worry about specifying positive angles because in geometry we didn't deal with negative angles. But here we have to think about that. All right, and then for supplementary, two positive angles are supplementary if their sum is pi. Okay, I heard something or saw something recently, because people have a hard time remembering which one's complementary and which one's supplementary. Pi over 2 comes before pi, doesn't it? C comes before S. That's just a simple thing, but if you have a hard time remembering, C comes before S, pi over 2 comes before pi. Just make it an easy way to determine which one is which. Okay, so let's think about this with this definition. If I have 2 pi over 5, if possible, if there are complementary and supplementary angles, I want to find out what they are. So if we're thinking complementary, and I'm just going to abbreviate, complementary angles, two positive angles whose sum is what? Pi over 2. So if I want the angle that's complementary to 2 pi over 5, I need to subtract that from pi over 2. So what do I have to do when I'm dealing with fractions? Common denominator. You never get away from that. So that's 10. 5 pi over 2 minus 4 pi over 10 is pi over 10. So our complementary angle to 2 pi over 5 is pi over 10. The supplementary angle, two positive angles whose sum is pi. So we're going to have pi minus 2 pi over 5. This one's a little bit easier. We don't have to think quite as hard because that would be 5 pi over 5 minus 2 pi over 5, which is 3 pi over 5. So 2 pi over 5 and 3 pi over 5 are supplementary. Okay, let's look at another one. 4 pi over 5. Find the complementary and supplementary angles here. 4 pi over 5 is already greater than pi over 2, so there is no complement. What about a supplement? Okay, pi over 5 is the supplement or supplementary angle to 4 pi over 5. If you add those together, then you get pi. So there may be times you cannot find a complementary angle. The two angles have to be positive. So if the given angle is already greater than pi over 2, it does not have a complement. If the given angle is greater than pi, it would not have a complement or a supplement. But you will run across a few where it asks you to find the complementary angle or the supplementary angle, and there may not be one. So remember, you have to have positive angles. Let's think about degrees. How many degrees is one complete rotation? 360 degrees. And we know that 360 degrees, if that's one complete rotation, that's equal to how many radians? 2 pi. So we're going to see if we can come up with a conversion factor. All right. So let's think about if half of a rotation in degrees, half of a rotation would be what? 180 degrees, and that is what in radian measure? Pi. Okay, so 180 degrees is pi radians. So we're just going, yeah. If I want to figure out what 1 degree is, I'm going to divide both of these by 180. Chemistry. Yes. And 1 degree is equal to pi over 180 radian, or pi radians over 180. Let me do that. I'll just erase that. 1 degree is equal to pi over 180. Let's go the other way. I have 180 degrees is equal to pi radians, and I want 1 radian, so I'm going to divide both sides by pi. So we know that 1 radian is equal to 180 degrees over pi. And these are our 2 conversion factors from degrees to radians or radians to degrees. You're right. Think about what you've done in chemistry. If we're going to go from degrees to radians, we want to end up with radians, so we're going to multiply by pi. And really, you don't have to put the radians, but it's pi radians over 180 degrees. We're trying to get rid of degrees, so degrees goes in the bottom. What are train tracks? How are you getting train tracks?
We do these conversions in chemistry, and we use these things called train tracks, and it's exactly like what you're doing.
Okay. And if we want to convert from radians, so you mean math has application in science?
Chemistry is math.
I know. And there's a lot of application, physics and math. We do a lot of physics applications in chemistry. Even in pre-cal, you get a lot of physics applications. Okay, if we want to go from radians to degrees, we want to end up with degrees, so degrees goes on top. We multiply by 180 degrees over pi radians. So Ms. Bartley has made this an easier job for you to remember. I have 135 degrees, and I want to convert that to radian measure. That means I want to get rid of degrees. So degrees goes on the bottom because they will end up canceling each other out. And we're going to put pi here. And you can write radians, you don't have to. It's understood that pi is in radian measure. So if we reduce this fraction, I'll just tell you 45 goes into 135 and it also goes into 180. This reduces to 3 pi over 4. About negative 270 degrees. Remember, I want to get rid of degrees, so pi goes on top. Okay, so we know that the degrees cancel. Those zeros are going to cancel. That makes it a little bit easier to reduce. It's going to be a negative. And 9 goes into 27, and 9 goes into 18. So 3 pi over 2. Yes. Okay, we got 3 pi. We're going to graph it. 3 pi is the same as 2 pi plus pi, is it not?
Yep.
So if I go all the way around, that's 2 pi, and I go another pi units, that's what that angle would look like. 3 pi is coterminal with pi. All right, let's go the other way. Negative pi over 2 radians. And I want to convert that to degrees. So if we're going to convert to degrees, we multiply by, I want to end up with degrees, so does degrees go on top or on bottom?
Top.
On top. And notice here, the pi's cancel, and we end up with negative 90 degrees. Nine pi over 2. Convert that to degrees. Okay, so we got 810 degrees. Now let's think about complementary and supplementary. With radian measure, complementary angles added to two positive angles whose sum was pi over 2. When we're dealing with degrees, two complementary angles whose sum is complementary
Is 90.
90 degrees. Okay, so you're going to be asked to find complementary and supplementary angles in degrees. Don't change it to radians. Keep it in degrees. They add two positive angles whose sum is 90 degrees. So if we're dealing with degrees, two supplementary angles would be two positive angles whose sum is 180 degrees. Okay, you're right. It's pi if we're in radians, 180 degrees if we're in degrees. So don't convert degrees to radians and find complementary and supplementary. Seems like every year that's what some of the students try to do. It's not that difficult in degrees. It's easier really for us to subtract from 180 and to subtract from 90 than it would be converting to radian measure. We're going to begin by first talking about angles. Now I know we talked about angles in geometry, but we're going to look at them in a little bit of a different light this year. In geometry, we couldn't have negative angles. In geometry, we didn't have angles that were greater than 180 degrees, I don't think. And so in trig, you can have both. You can have angles that are greater than 180 degrees, and you can also have negative angles. So I want to begin by first just let's get a basic definition, a trig definition for an angle. All right? For an angle, we rotate a ray around its endpoint. We're thinking more in terms of rotation than necessarily two separate rays that are joined at their endpoint. If we are talking about angles in trig, an angle that's in standard position will have the vertex at the origin, and its initial side will lie on the positive x-axis. This would be the initial side. Now, if you were to think about this being, my hands being that one ray, you would take that, even though this stays here, and rotate it around the vertex. So as you rotate, you could have an angle here. This would be considered the terminal side. And, of course, this is our vertex. Okay, this is an example of an angle in standard position. We could have another angle in standard position. I'll just change colors. Again, its initial side would be on the positive x-axis, but maybe its terminal side would be in the second quadrant. That would be the terminal side. Remember, that is an obtuse angle. It's between 0 degrees and 90 degrees. The red angle is an acute angle. It's between 0, did I say that right? The obtuse is between 90 and 180 degrees. The acute is between 0 and 90 degrees. All right. If we have positive angles, the rotation is counterclockwise. Positive angles have a rotation that's counterclockwise. Negative angles have rotation that's clockwise. Starting from the initial side. The rotation's clockwise on a negative angle. An example of a negative angle, let's see, we'll do it in green. Might be like this. If we're going this way, that would be a negative angle. If we start at the initial side and go in a clockwise motion, those are considered to be negative angles. Some different, I don't think we use these in geometry, but different ways that angles can be labeled. Yes, sir?
So would the red one be a positive angle?
That's a positive angle because we're going in a, we could also name it as a negative angle, and we'll talk about that in a few minutes. But if we're going from initial side in the counterclockwise, this is a positive angle. The blue one, we are going, if we go from the initial side to the terminal side, that would also be considered a positive angle. Okay, some different ways that we label angles that you've not seen before. Maybe theta with Greek letters, that's theta. We might see alpha. You might see them labeled beta.
What's the first
But
one?
it is theta,
Like
a circle with a line through it.
oh, okay.
Okay, these are Greek letters, and these are common ways that angles are named. You might see any of them. If you've got multiple angles you're dealing with, you could see any of those Greek letters. They might even use different letters other than that, but we usually in trig, we label angles with Greek letters. So you might see alpha, you might see beta, or theta, mu. Different Greek letters designate angles. Okay, you asked just a minute ago if the angle in red was a positive angle or a negative angle. I think you could see, you could name it either way, depending on how you rotate. But angles that have the same initial and terminal side, the same initial and terminal side, are called coterminal angles. If they have the same initial and terminal sides, they are called coterminal angles. And I just abbreviate angles. If they have the same initial and the same terminal side, they're coterminal angles. And they differ by 100 or 360 degrees, if we're thinking about degrees. Now, we've worked with degrees before. I think I already mentioned calculus works with unit circle or radian measure. So we're going to examine radian measure today. And we will be dealing with both. Degrees deal with right triangles. The unit circle deals with radian measure. All right, so before we talk any more about coterminal angles, I want us to define radian measure.